Your multi-agent system fails on a real task, but this time you captured every trace, token, and tool call. You did the instrumentation work, yet an hour later you still cannot identify which decision actually broke the run. I'm Merdad, and this video is about observability and failure attribution inside an agent harness. Logging every step and knowing what went wrong sounds similar, but they are two very different capabilities. A complete log can tell you exactly what happened at each step without telling you why the overall run failed. You can scroll through every message, tool response, and retry, then finish with several plausible explanations instead of one defensible answer. The evidence is present, but the diagnosis is missing. Collecting the data is the easier half of this problem. Turning that data into a causal explanation is the harder half. Observability gives you visibility into the run, while debuggability helps you isolate the decision that produced the bad outcome. That distinction matters because agent failures often travel downstream before they become visible to monitoring or users. An early assumption can contaminate planning, search, and synthesis, even though the obvious error appears much later. So, the useful question is not whether you can see every step, it is whether you can name the step that made failure inevitable and explain how its effects propagated. Start by instrumenting an agent run like a distributed system because attribution is impossible when the evidence was never captured. Traces connect every agent, step, and tool call into one navigable execution path that you can inspect and replay. Metrics expose changing system health through latency, success rates, retries, and loop depth across many runs. Logs preserve the detailed inputs, outputs, and relevant reasoning at each step, while cost records tokens and spend by step and intent. These four layers are necessary foundations, but they remain raw evidence until something interprets the causal chain. Failure attribution asks two related questions that ordinary observability tools rarely answer for you. The first is who. Which agent introduced the problem or failed to correct it when correction was possible? The second is when. Which exact step changed the trajectory enough that failure became likely or unavoidable? Naming the agent gives you a responsible component, but pinpointing the decisive step gives you a mechanism you can repair. Attribution turns a replayable recording into a diagnosis, which is where the difficult and valuable work begins. In this trace, monitoring flags the visible error at step 9 so that step naturally attracts the team's attention. But step 9 is the victim, because the run was already compromised by a bad assumption at step 3. Search and synthesis inherited that assumption, carried it forward, and eventually produced the failure several steps later. If you patch only the visible error, the same causal defect can surface again somewhere else in the run. Effective attribution follows the propagation path backward and fixes the origin, rather than blaming the place where damage became visible. Handing the trace to a strong model sounds reasonable, but current evidence shows an important gap in attribution quality. Models can often identify the responsible agent from a full trace, making the who question workable in many cases. Pinpointing the decisive step remains much weaker because several downstream actions may look suspicious after one early decision shaped them all. Output-only traces make this harder by hiding the inputs and context that influenced each decision. The practical lesson from who and when and trace elephant is clear. Capture the full execution trace because causes often live in what an agent saw, not only what it said. Debuggability is a property you design into the harness before an incident, rather than a feature you add afterward. Full execution traces preserve the causal path, replayable steps support controlled investigation, and per-step cost reveals waste hidden inside successful or failed runs. The model produces behavior, but the harness determines whether engineers can understand that behavior when something goes wrong. If the architecture discards inputs, context, or step boundaries, no dashboard can reconstruct evidence that was never retained. Here are 3 takeaways to carry forward. First, complete logging provides observability, but it does not automatically identify the cause of a failed run. Second, attribution must answer both who was responsible and when the decisive failure entered the execution path. Third, capture full inputs, context, traces, and per-step cost, then trace backward from the visible victim to the true origin. Do not just watch the run, design the harness so your team can explain and repair it. If this series is useful, subscribe to Multi-Agent Academy, and you can also connect with me on LinkedIn. Next is video 15 on governance and policy management, where governance becomes an enforced runtime layer instead of a document sitting in a wiki. Policies only matter in production when the harness applies them during execution. I'll see you there.